Thyristor operating principle. Thyristor has a three-terminal p-n junction G1, G2 and G3. When anode is a positive potential with respect to cathode into no voltage applied at the gate junction J1 and J3 and forward bias while junction G1 and J2 in reverse bias. The IV characteristic of SCR is split into namely two types, forward bias and reverse bias. In the reverse direction, anode to cathode voltage negative is similar to reverse bias diode. In forward characteristic, the anode is a positive with respect to cathode, hence SCR is a forward bias. The forward bias characteristics are divided into three regions: forward blocking state, on state and transition state. The operation of SCR. The gate terminal of SCR is left open, that is Ig is equal to 0. SCR is a forward bias. By applying the positive voltage to anode with respect to cathode, out of the three junctions, the junction J1 and J2 are a forward bias and junction J2 is a reverse bias. Therefore, current flow does not flow through the SCR. The entire applied voltage appears across the junction J1. As the anode to cathode voltage is increased, the voltage across junction J2 is increased. At a certain voltage, this junction will break down. The SCR will start conduction. This voltage is called as a forward breakover voltage. It is possible to turn on the SCR without any gate current to excess in a forward voltage beyond it. A turn-on method of SCR. SCR is a turn on the increasing the anode current. This can be achieved with one of the following way. First is by raising the temperature, that is thermal triggering. Second one is focusing light, that is optical triggering. Third one is applying high voltage, that is forward voltage rating triggering. Fourth one is by applying voltage to high, that is dy by dt triggering. Fifth one is by increasing the gate terminal, that is gate triggering. By raising the temperature, that is thermal triggering. In this, if the temperature of SCR is increased, there will be increasing the number of electron hole pair. This will increase the leakage current. Therefore, the value of alpha 1 and alpha 2 will increase. If alpha 1 plus alpha 2 tend to unity, then SCR can be turned on. Next one is by increasing the gate current. As already discussed, the breakdown voltage will decrease with increasing the gate current. In gate triggering, the gate current pulse of sufficient amplitude and duration is applied to the gate terminal of the forward bias thyristor is turned on. When we can turn on the thyristor at the desired value of firing, the angle alpha will get triggering. The gate signal should be removed once thyristor is turned on. The gate signal should not be applied continuously in order to avoid the gate power dissipated. Gate current should not applied when the thyristor is reversed, because then the thyristor may fail due to the increasing leakage current. The advantage of gate turn on: less power consumption. If it is possible to turn on the SCR, that is desired value of anode to cathode voltage. Turn on gain: the ratio of anode to gate current. For gate turn on, the method of turn on gain is a very large. Turn off process: once SCR is a turn on, the gate latch into on state and act like a closed switch. The gate terminal loss control over SCR, that is, even through the gate pulse or forward SCR remain on the on state. A conduction SCR can be turned off with the help of external circuit by reducing the anode current below the holding current for a remaining specific time. During this time, the store change inside the device, like removing pulse, due to the internal recombination of carrier. The turn off time of SCR is depend on the current through SCR. Second one is a dy by dt at the time of it, SCR is a turn off. The junction temperature and the magnitude of reverse voltage. Increase the value of the factor 1, 2 and 3 will increase the turn off time, where with the increase in the reverse voltage, the turn off time will decrease. The turn off SCR: as long as the forward current exists, there are two ways to drop the SCR out of conduction: anode current and force communication.